Hello everyone, my name is Iman and I'm a researcher in the EVREF team. So I'm new for the Pharo community and I'm working on detecting vulnerabilities in application written in different languages such as the Java language, and I'm trying to do attacks on Pharo language or Pharo code. So today's presentation is about constructing and building attack chains in Pharo. And this work is done with my colleague Steven, who is here. So let's start by diving into some attacks. In 2016, there is an attack which is called SFMTA attack, which is a ransomware which targeted the public transportation company in San Francisco. So this attack is of kind of deserialization. I will explain to you what is deserialization. It takes 2 days to be resolved. So there are a lot of computers that were that were locked up, and there are a lot of services of this transportation agency that were locked. But after the 2 days, it was resolved. But the bright side of this attack is that there are a lot of passengers that had free rides for 2 days, even though it was an attack. There are also more recent attacks. For example, the attack of the town hall of Lille last year, which affects a lot of citizens here, and there are a lot of services that were blocked for more than 3 months. So for more than 3 months, there is an attack, and services they were not working. So they come back to paper version in order to do normal services. Each attack which is detected and studied is stored in what we call a database of CVEs. So what is a CVE? A CVE is for common vulnerabilities and the exposures, and it is like the identity card of an attack. So you give an identifier to the attack, a description of the attack, how it is happening, and of course, if the patch is existing for this attack, you can add the description of that. And there are a lot of known databases for CVEs. For example, the most known one is the second one, the Mitre Corporation, in which there are a lot of CVEs that are describing attacks. And there are also other databases like the Red Hat and the NVG database. Now, let's do a little look on CVEs for some keywords. For example, for the Java keyword. We found more than 2,800 CVEs that describes attacks against Java. We did other research about other attacks, for example, about SQL injection, and we found more than 14,000 CVEs. That means that there are more than 14,000 attacks on SQL injections. And we do with other research for Java injection, Python, etc., and we found a lot of CVEs. Now, what about Pharo? Are there CVEs about Pharo? Are there attacks about Pharo? So we do the same thing, and we found that there are 0 CVE against Pharo code in this database, of course. And with the same manner, we did the research for the Smalltalk language, since Pharo is linked to Smalltalk, and also there are 0 CVEs. So does that mean that Pharo is safe? We do not know. So our question is that, is Pharo safe? If it is the case, then we are happy, everything is fine. But if it is not the case, so we should know how to do potential attacks. What are the potential attacks against Pharo? and how to prevent them. And to do that, we will write a proof of concept of attack against Pharo. I told you that I will talk about deserialization attacks. So deserialization, I was working in previous research work with other collaborators on deserialization attacks in Java. And I will show you what are deserialization attacks. So when you say deserialization, you say serialization. Deserialization mechanism is useful for storing data. It is very useful for storing data. It is very quick, better than storing objects. So you deserialize them, and then you can use them directly. It's more good for memory management. And it is the deserialization concept. It is coming from serialization, deserialization. When you say deserialization or serialization, you have an object, and you will transform it into a byte stream. For example, here, my screen, the bottom, you have the object MC, and you will transform it into this byte stream. This is the serialization. And the deserialization, it is the opposite process that will transform your sequence of bytes into the original object. This is good. But when the attacker introduces some malicious data in this sequence, then it can lead to attacks that can be very dangerous, that can go to remote code execution in the victim's machine. Here I give you an example of an attack against PayPal, which is which takes place in 2015. Don't worry, because this attack was not happening. It was, the story is that it was, there is a researcher, a security researcher, who was trying to attack a particular service which is called manager.paypal.com. And he found that there is a field which is called old form data here, for which if he gives this highlighted sequence of stream, or this stream, he can get access to all the users of the information of this manager.paypal.com service. So by personal information, you can imagine, for example, credit card numbers, bank account addresses, phone numbers, etc. So he was preventing PayPal, and this was corrected after 3 days, I think. 3 days, and PayPal gave him some amount of money to thank him. So deserialization attacks, how they are happening. You have, in the left side of the screen, you have the attacker side, who will do some magic things, will write malicious code to generate a malicious file. So, malicious file that is containing malicious data. Then he will give this malicious data or malicious file to the victim, who will deserialize, who will try to read the content of this file. And once he starts the deserialization process, then the attack will take place. For example, the action of the attack may be stealing the sensitive information of this victim. To study in depth the deserialization attacks, we were using a tool which is called YSOCerial. So it's very a nice tool, which is giving a proof of concept for 47 attacks in Java, deserialization attacks in Java, and we were studying 19 out of these attacks. And our goal is to understand how these attacks are happening and to extract a maximum of information to see if we can reuse these concepts and this information to do attacks in other languages and to prevent these attacks. I show to you here two call stacks of two attacks in YSOCerial. The first one on the left side is for JGK 7 update 21 version, and the other one is depending on a library which is called Commons Collection 3.1. And when studying these call stacks, we were extracting what we call gadgets. So a gadget is a method that is using a field or attribute that can be controlled by the attacker. For example, in Pharo, you have the method readFrom, which is taken as parameter a stream or a string, which can be controlled by the attacker. Then we consider it as a gadget. Now we go further and we try to see what are the internal mechanisms that are used in these attacks. So we found that attacker is using reflection, is using also native calls, and some classes and methods that we judge that are vulnerable. For example, the classes, the transformers classes in Java are classes that are very vulnerable in our point of view. After studying all these attacks, we have two main observations. The first one is that the attacker is not using new concepts in his attacks. He's using just existing concepts. He's not inventing new things that are extra. So just existing concept. And the second thing is that the attacks are are done because there are some vulnerabilities or some weaknesses in the code. And these weaknesses are not localized in only one part of the code. They are distributed in many places. So that's why we call that it's a constellation of many methods invocations that are communicated to form what we call a gadget chain. So they are distributed in the code in many places of the application. So now that we have understood how the serialization attacks are happening, what are the internal mechanisms, etc., we would like to reproduce that in Pharo and to do an attack in Pharo. But before that, we need to know what are the ingredients for that. So we need some ingredients for the serialization attacks. First of all, we need a malicious code that will generate a malicious file from the attacker side. Then we need to know that there are some versions of the language that are vulnerable and some methods that we will invoke that we will use in our attack to do the action of the attack. And then we need to just to communicate what we generate, the malicious file, to the victim. That's what we call sending malicious file to the victim in order that it will be deserialized to do the attack. Here is the code that we wrote with Steven about for generating the malicious file or the malicious string. So first of all, we will capture. This attack is the action of this attack is stealing the SSH keys of the victim and sending it to website of the attacker. So first of all, we need to capture the user's path in order to collect the SSH files in this path. Then we will create a dictionary in which we will put the content of the SSH files, the stolen SSH files, and after that we will send this to the address of the attacker website. So to the attacker website we will send these files. And since it is an attack, we need sometimes to hide the code of the attack. So we will just translate all this code into a byte array in order to put it unreadable by a human. And this is the result of the code of our attack. So obtain by a stream that is unreadable by a human and that will be used just by the method readFrom so in the victim's machine. So the victim will just call this method readFrom with this string, and then the attack will take place. I told you that the method in our point of view, the method read from is a gadget. So because it is calling or it is using this parameter, which is text string or string, which is attacker controlled. So here I would like also to underline that the fact that in the read from method, there is the method evaluate that is also taken as parameter an attribute that is controlled by the attacker. So evaluate is also a gadget. Consider it as a gadget or as a weakness. Now that we construct our attack, we would like to show to you how the attack is happening. So here is the malicious string that we built. And once deserializing, what is important here is this call stack of the attack, which is calling, so using the method read from of the malicious string, and which will call the evaluate method to evaluate the content of this malicious string. And there will be a lot of other calls of other methods, and at the end we will arrive until the call of the method post of the ZN client that will send the malicious the stolen files to the attacker website. I take here an example of an existing website. So we are happy. We succeed. The attack is done. But that means that we need to put more security checks when we are writing codes in Pharo. So as a future path of our work, we think that it is good to get a look on the method read from, which contains a weakness, which is calling the method evaluate, and either to remove, for example, the call to the method evaluate, or to deprecate this method read from and remove it then, or to put more control on that method. Another thing is that in the study of deserialization attacks in Java, we have a concept or mechanism for protecting against deserialization attacks, which is called the security manager. So this concept of security manager, it does not allow deserialization attack to happen in Java, and it's powerful mechanism in my point of view. So why not? This concept is not existing in Pharo, so why not introducing it natively in Pharo? And what I mean by natively here is that even though the developer who is writing or who is using the read from method, he is not calling the security manager explicitly, it will be called implicitly when executing the code in order to protect it. And one last thing is that the main problem of the attacks, mainly this, for example, the deserialization attacks, is that they happen because there are openings to the outside of the application. For example, when you are using reading external file, or when you are doing query to a database, you have contact with the outside. So why not controlling these openings to the outside, detecting them first, and then putting more control on them? And this is what we are doing currently. We are working on what we call security cards to detect these openings and to protect them more in applications, so in Pharo. To conclude this talk, vulnerabilities and weaknesses are still existing in object-oriented languages and in Pharo. We did 3 attacks on Pharo. I showed to you just one attack, but we did 3 attacks. And in our point of view, it is very relevant that we add security checks when we are writing code in Pharo. Thank you for your attention, and if you have a question, you are welcome.
Do you have a question?
So the vulnerability you showed was that the Pharo object read from calls the compiler evaluate, which can insert arbitrary code, so that's scary. But in what scenario can the outside attacker reach that part, call the object read from? What is first then?
I can imagine, for example, you have a website. For example, there are some applications that are written in Java, and you have the fields to fill with your. I showed to you the PayPal attack, for example. In the PayPal attack, you have the. I will just come back very quickly to the PayPal. Here. You have the fields to fill in. So here, implicitly, you have the call of the equivalent of the read from method, but in the language in which this website is written, or in the background of this interface, user interface, you have the call of the read from. So this is the first manner in our point of view. Yes.
Yeah, I understand. But did you have an actual example of where something was open on the internet and doing that?
Just if I can add, because I'm working with Iman, and the case of read from also, I found it once in something like Stack Overflow, like, oh, to debug this, you can execute this piece of code, and so people are debugging and will copy paste their piece of code and try to execute it to get more info, and you can make a script that will get your SSH key and then answer the questions that you wanted on Stack Overflow.
Okay.
This may not be too relevant for Pharo, but in other Smalltalk dialects, things like this reading in of code is used for shipping fixes for existing packaged applications. And that's, of course, a very difficult open door. So maybe that's a potential attack vector there.
Yes.
So what I would think is that protecting the executed code to detect external access would not really solve the problem, because attackers would know of that protection and then do something like compiling a more difficult to detect pattern, like introducing finalizing methods or other stuff that will be called much later than the actual evaluation lead. So this will not help overall.
Yeah, in my point of view, it will not prevent all the attacks, but at least it will minimize the number of attacks. But yeah, I agree with you. Attackers are finding all the time new manners, but we are here to try to. Yes, please.
Maybe that's the same question, but out of my head. You mentioned that you could imagine mechanisms that check that read-in file and make sure there is no malicious code in there. But that still is, what mechanism would that be? I mean, there can still be, I mean, you only find what you look for, like in chemistry, so how would that work? So you're reading in Smalltalk objects that will be executed code, or you read in code, and what would you do with that code in order to make sure it's not doing any malicious?
So the idea is not the reading the content of the files. It is just to put more control on the methods that are reading external content. The methods, for example, read from, we put more restrictions on using it, for example. But
what's the idea here? I mean, is it something like I filter whatever comes in with these criteria, but that only prevents things that I'm thinking of in advance, right? So
yes, it can be filtering, it can be low deny list, it can be a lot. But my colleague wants to answer. Maybe it's more precise.
So we only have ideas at the moment, but for example, if you have some kind of security manager, so to speak, that you can configure, you could say that, for instance, you constrain that the code that you read from the deserialization code that you execute, for example, should not execute code that is not from packages that you trust. So it should not create strange objects, or of course it's limited because you can always find, each time you find you put a security door, the attacker tries to find another entry, but it limits it reduces this possibility. So the idea we have for now is to use a reflection ourselves to check if the code executed comes from the package you trust or not, and in that case you could just interrupt and ask the user, is this normal or not? For example, that would be a starting point.
Here, if I may, I show to you the reaction of the security manager in Java when you are trying to attack using the read object method, which is the equivalent of read from. It stops the execution of the attack, and it shows to you that there is access denied to a class which is in a package that for the security manager it is not safe. So he classified that as not safe, then he stops immediately the execution. So we would like to do the same thing, but in more in better way.
Yeah, the question if isn't it a futile try, because as long as you can transfer code, then you can just, in many cases, just a matter of how complicated you make that they get through any security manager. So the right thing to do is just to prevent the possibility of executing remote code. So yeah, it was in former times. It was also the problem with the JSON format. JSON actually was just taking the string and then sent it to compiler, and then people discovered, oh, I can just it's not necessary to have a little there. You can also execute any code, and then all the libraries switched to parsing. And here's the same thing. If you want to serialize objects, you never should evaluate something and have access to the compiler, but just parse the data format. And I think this is the only right way. You should never have access to execution engine when transferring data.
Yes. So we have an idea in the past, is that when we see that there are, for example here, you see usually in remote code execution we have the call of the runtime exec method in Java. So for us, deserialization should not call the execution of something. It should just deserialize. It should just rebuild an object. But if we found that there is call to a method which is called exec or execution, then there is something strange. So we should block that.
Sorry, just to go
Yes.
in the same direction, I think maybe the solution is to analyze the code used by the developers and inform them that they use potentially gadgets, and maybe they don't know they use that, and sometimes they have to find another solution more secure to do the same thing. Oh no. Okay. And I don't know, so if maybe it's a tool that we have to add, not just only a security blocking thing, but something that informs the developers that it's not okay to publish that.
Yes, as a first step of our work, we would like to introduce a tool. That the first step is that it will just prevent the developer when he is using. He will get a message, be careful, this is a method which is potentially dangerous. And as the next step, it will try to, if there are a lot of methods, imagine an application with thousands of methods, it will not do a lot of messages, then it will maybe block when it judges that there is an attack. And it's not easy to decide, so that's why we are working on that path to characterize these methods or these gadgets, to say when should we say or judge that this is a gadget, a real gadget.
Yep, here. What you present is basically a way to those gadgets to be aware of them and have like a defensive mindset when you're programming. But wouldn't a cryptographic signature solve the issue of deserializing something that was mutated? Because if, let's say I serialize something and I sign it cryptographically using HMAC or any other messaging, something that signs what I'm serializing. If somebody modifies that, on the other side, the checksum won't match, and then I won't deserialize it. I remember in the past some, I think it still does, some Amazon things need you basically to sign whatever you're posting there. So there's no way I can build a malformed sequence of bytes and have that ingested by any other system, unless the other system was naive enough just to process anything as is. I mean, this is more, I think, of a mindset and not a technical thing.
Yes. For the moment, I maybe, but I'm not sure that it is yeah, I don't know. I have to check that and to see that.